Hello everyone, welcome to my channel. In this video, I'll discuss the concept of ABCD parameters. ABCD parameters, also called as transmission parameters, general circuit parameters, or chain parameters. These parameters are widely used in transmission line theory. In transmission line theory, 1 dash port will be acting as sending end and 2 dash port will be acting as receiving end. And also this ABCD parameters are widely used in cascaded networks as well. And this is a two-port network shown. This black box represent a network, and we have a pair of terminals 1 dash and 2 dash. 1 dash becomes one port, 2 dash becomes another port. Port is nothing but a pair of terminals in which signal can enter or leave. Corresponding variables to port 1 are V1, I1, and corresponding variables to port 2 are V2 and I2. ABCD parameter equations can be written as V1 equal to AV2 minus BI2, I1 equal to CV2 minus DI2. Here the negative sign is used with I2 and it is not for the parameters B and D. Matrix representation of above equations can be written as V1 I1 equal to matrix A, B, C, D, and this is V2 minus I2. This matrix is also called as transmission matrix. Let us write the parameters, ABCD parameters one by one. Main equations are V1 equal to AV2 minus BI2 and I1 equal to CV2 minus DI2. From first equation we can write A equal to V1 by V2 when I2 equal to 0. And B can be written as V1 by I2 when V2 equal to 0. And we'll have minus sign here. C equal to I1 divided by V2 when I2 equal to 0. And D can be written as minus I1 by I2 when V2 equal to 0. Coming to the definition of A, here the condition is I2 equal to 0. So we can define it as open circuit. Next, the ratio is here port 1 to port 2 ratio. So we can write it as a reverse. And here the ratio is V by V. V by V is nothing but voltage gain. Therefore, A is defined as open circuit reverse voltage gain. Let us look at B now. What is the condition here? V2 equal to 0. So we can write it as short circuit. Next, look at ratio. It is the ratio of one port variable to the second port variable. So we can write it as reverse. And here it is nothing but V by I. V by I is impedance. So you have to write here as reverse transfer impedance. B is defined as short circuit reverse transfer impedance. Next, coming to C. The condition is I2 equal to 0. So we can write it as open circuit. And the ratio here is 1 to 2. Port 1 variable to port 2 variable. So it is again reverse. I by V. I by V is nothing but admittance. So you can write it as reverse transfer admittance. Next, D. Condition is V2 equal to 0. We can take it as short circuit. Short circuit and ratio is port 1 to port 2. So you can write it as again reverse. Ratio is I by I. I by I you can take it as a current gain. This is how we can define the variables A, B, C, D. First, look for the condition. If condition is I equal to 0, you start with open circuit. If the condition is V equal to 0, start with short circuit. Then look for the ratio, whether it is at port 1 or port 2, or whether the ratio is port 1 variable to port 2 variable. If the ratio is port 1 variable to port 2 variable, you should write the word reverse. If the ratio is port 2 variable to port 1, you should write it as forward. If it is V by V, you can take it as a voltage gain. If it is I by I, you should write it as a current gain. If it is V by I, you should write it as a transfer impedance, and if it is I by V, you should write it as a transfer admittance. This is how we can define A, B, C, D variables for ABCD parameters. That's all for this video. Thank you.